When you think about fractions, we always want to get them in simplest form. And a radical expression is in simplest form when the following criteria are met. No radicands have a perfect square other than 1. No radicands contain fractions. And no radicands appear in the denominator. This is the one that we're going to look at today. When a radicand is in the denominator and not a perfect square, you want to multiply the fraction by an appropriate form of 1 to eliminate the radical. And I'll explain what that means. But this is called rationalizing the denominator. So let's look at this one. Now, if you were to split this up, you would say this is the square root of 1 over the square root of 3. Well, the square root of 1 is 1, but the square root of 3 doesn't reduce. And technically, a fraction is not simplified if it has a radical in the denominator. So what you want to do is multiply by that radical, and look at what happens. You'll get square root of 3 on the top, and then this gives you the square root of 9, which is 3. So, couple things to point out right here. You cannot divide these 3's because this is an integer and this is a radicand. So, you cannot reduce them. The other thing is that while the answer has a radical in the numerator, the rule is that it's not allowed to have a radical in the denominator. So, technically, while it doesn't necessarily look any better, this is considered simplest form. There are these things called conjugates. And conjugates are two binomials that look exactly the same, only one is plus and one is minus. So when you have an expression that's more complex than what we just encountered in example 1, you can use what are called conjugates to help you get that radical out of the denominator. So you see in example 2, we don't just have radical 5 in the denominator, we have 3 plus radical 5. And you can't multiply by radical 5 over radical 5 like we did up here, because that won't eliminate. It will actually create more radicals than you want in the denominator. So the way that you get rid of the radical this way is you multiply by the conjugate. So I'm going to multiply top and bottom by 3 minus the square root of 5. Now, these are conjugates. And if you think back to when we did difference of two squares, when you had the same thing, but one was plus and one was minus, the middle terms canceled. So let's FOIL the bottom and see what we get. Well, we know the top is going to be 3 minus square root of 5 because it's times 1. But let's see what happens on the bottom. So we get 3 plus the square root of 5 times 3 minus the square root of 5. So I'm FOILing out that denominator product. Here we go. 3 times 3 is 9 minus 3 square root of 5 is the outside. The inside gives me plus 3 square root of 5. And the two last terms give me the square root of 25. Well, remember I just told you the middle terms will end up canceling. And the square root of 25 is the number 5. So you just have 9, the whole middle piece canceled, minus 5. And 9 minus 5 is 4. So this whole bottom piece turns into just the simple number 4. And since nothing else is in common, this is the simplest form answer. Yes, it still is a radical, but it's not in the denominator. All right, let's check out an example. The distance in miles, which is d, that you can see to the horizon with your eye, h feet above the water, is that equation. How far can you see when your eye level is 5 feet? So this 5 stands for h, because h stands for the feet, and d stands for the distance in miles. So I'm going to plug in 5 for h and see what happens. I get d equals the square root of 15 over 2. So let's see what that turns into? Well, I can break that up into the square root of 15 over the square root of 2. And nothing reduces, so I'm going to multiply top and bottom by the square root of 2 over the square root of 2. Numerator gives me the square root of 30, and square root of 2 times the square root of 2. I'll write down that that's the square root of 4, but I'm going to just shortcut and write that the square root of 4 is the number 2. And that's as far as you can go. The answer is in feet. Nope, the answer is in miles. Sorry. If you want to turn that into a decimal, you can. If not, I'm totally cool with you leaving it just like that. If you have any questions, write them down and ask me when you see me next.